Okay, so hello everybody and welcome to this invited talk. It's my great pleasure to introduce Professor Kachel Gurin from Dublin City University. As you probably all know, he's a lifelogger and he's going to talk about lifelogging. Yeah, he's actually wearing the camera 24/7 all year, basically, since many years, all the time. Yeah. Just a few words about him. So, Professor Kachel Gurin is the head of the ADAPT Center at Dublin City University, and his research is on personal media analytics, user modeling, and lifelogging, of course. He is interested in building rich multimodal user models and deploying them to solve real-world challenges using AI. And he has been the general chair of many leading international conferences like ECIR 2011, MMM 2014, CBMI 2019, ACM ICMR 2020, MMM 2022, and will be co-chair for ACM ICMR 2024 and ACM Multimedia 2025 and ACM Web 2027 in Dublin.
All the proposals were successful. It was a bad outcome from my point of view.
That's a great achievement. Yeah, and he's also, of course, the founder of the ACM Lifelog Search Challenge. So please welcome Professor Kachel Gurin, and I'm looking forward to your talk.
And thank you for coming. And yeah, as Klaus said, my name is Kachel Gurin from Dublin City University in Ireland. Spent time as the deputy head of department, the acting head of department, now head of the ADAPT Center. So I'm hoping to get more research done than administration done in the next couple of years. I'm going to talk briefly about the kind of work we've done in building lifelog search engines. I kind of have always viewed it as being a search challenge to manage large lifelog archives. My background was doing a PhD in web search, then doing postdoc in multimedia search, building video search engines that took part in TrekVid back a long time ago, building video search engines that went into Samsung TVs and just did kind of video search stuff, but I kind of got bored and I realized lifelogs is where I wanted to be. So I'm going to take you through a quick journey into this. This was the research team over the last few years. A lot of people have left already, but as you see, we're extremely gender balanced and very diverse as a research team. But all these guys did the work I talk about. It's not my work, it's really their work. So we want to highlight that. And of course, they come from all over the world, and that's really important as well. So I kind of start back in 1945. Many of you will have come across the Memex by Vannevar Bush, where he described what is essentially a physical manifestation of a lifelog built into a desk. He talks about a future device in which you store all your books, records, and communications mechanized, retrievable with exceeding speed and flexibility. It's essentially a digital memory. And this was, of course, instantiated in the article As We May Think from 1945 as a desk with technology of the time, pulleys, some kind of keyboard, some kind of microfilm scanning system. It couldn't be built, fine, but it introduced us to the concept of personal data organization, and personal data linkage, where links were automatically generated between different content. And Vannevar Bush introduced us to that, and about 30 years later, Gordon Bell built that. Well, probably 50 years later, Gordon Bell built that. He built a tool called My Life Bits, working with Jim Gemmell in Microsoft, and they tried to build what we describe as being a lifelog. They tried to capture all of Gordon's data. Let's say it is all the data we have about Gordon. What he watched on TV, radio he watched. He would have had a secretary scan all the books he read, all the magazines he read. He had help to do this. It was still quite a manual challenge. And if you notice, Gordon's wearing a camera around his neck. Gordon worked at Microsoft after leaving Digital Equipment Corporation, doing essentially anything he wanted to do in Microsoft research in San Francisco. And he had health issues. And he'll say this, he had a quadruple heart bypass. He went to the doctor, and the doctor said, "So tell me, Gordon, when did you first feel like this?" And Gordon said, "I don't know. I can't be sure." And he thought, look, we have the technology nowadays to go and build a life log that I can then use to answer the doctor's questions. And we thought about the health side, we thought about everything else as well. So we ended up building the life log, my life bits, and ended up starting the project to build the wearable cameras out of Microsoft Research in Cambridge. And how we came to do work in the area in DCU was Microsoft Research in Seattle had 12 cameras that they offer to researchers around the world, or maybe even a few more than that. But 6 groups around the world got 2 cameras and $50,000 to go and do research. And we got 2 cameras and $50,000, the only non-US group to get access to these. And of course we had a camera, like Gordon's wearing, about the size of my car key here. And nobody wanted to wear it. We had these 2 cameras. It was May 2006, and we realized in order to build what we wanted to build, which was organization models, somebody had to gather data. Who wants to gather data and give me your camera data for 2 weeks? Everything you do. Anybody? Anybody? That's what it was like. So I said, I'll do it because I was going to Norway for 2 weeks. I figured nobody really knows me there. It's okay. I can wear a big black camera and I'll probably get away with it. So I went to Norway, and I kind of realized this was an interesting challenge. I had done work on web search, as I said. I'd done work on video search, and I thought this was the most interesting thing I've come across. At the same time, Gordon had already given a lecture, the keynote talk at ACM SIG-IR in 2004 in Sheffield that I was at, and I thought that was really interesting back then. And then 2 years later, we have the cameras he's talking about, so let's go and do it. So this is what I wanted to do. I wanted to go and build life experience capture tools and then build positive applications on top of that. Here's the picture of me taking a picture of a street in Tokyo, captured by a Google Glass in terms of life logging tools. So we looked at it as being something like this, and I'm going to go through this pretty quickly. We try to capture large aspects of what we do. And sometimes we capture more data than other times. We almost always capture what you see in terms of a wearable camera. I'd love to have it here, but there's nothing with a sufficient battery, so we wear something here. Anyone that was at my class today would have seen Graham's lecture on capturing attention to understand via EEG how we can identify when somebody's paying attention to something, when somebody recognizes something. That's a cool thing we sometimes do. We've done some work on speech, capturing audio in the environment, but we found, interestingly, that people didn't really care too much about wearable cameras, capturing pictures, but they really cared if something captured sound, because that captures what you say and can be played back to you. So we didn't do that much on speech. One of my colleagues, Aidan, wore an MP3 player about 2010 for 2 weeks and nobody spoke to him. He was a PhD student in a research group doing life logging, right? So there's a definite challenge there. Biometric data from smartwatches, we gathered that, we'll see that in a moment. Locations from our smartphones, very useful for finding something. And of course, activities. I was walking, I was driving, I was eating as part of our data gathering process. For biometrics, in reality, depending on whatever you want to measure, there is something to do it, be it sleep, be it stress levels, whatever it is, there's going to be something there to carry your data. The only challenge you will face is, can you get access to it at a sufficient granular level, like every minute, to go and use it in your search engine? This is a challenge. Not every service gives you access to the data at the granularity we want, which is always going to be a problem. And then how do we see this life logging thing fitting into the ecosystem of personal data? Anybody that has a smartwatch, and probably most of you are wearing a smartwatch or some kind of smart ring or some kind of smart tool to gather your personal data, is what we call quantified self. Quantifying yourself, converting your life activities into numbers. Many of us do that, be it footsteps, be it kilograms, be it distance walked, be it hours slept, something we do to analyze ourselves in order to improve some knowledge about ourselves, or get some knowledge about ourselves and use that to improve our life. Sleep better, eat better, walk more, exercise more. And that concept where you gather data driven by a user need, I want to lose weight, I want to live longer, I want to be healthier, is what we're very used to. Life logging we see as being a little bit different, which is we try to generate this digital twin of everything we do. We won't always know exactly what we're going to do with the data. And that's a key difference between what we're used to doing, where we gather data in an ethically sound manner because we have to do an experiment, versus a challenge now is you gather data and you're not really entirely sure what you're going to do with it, but you know it's probably going to be useful. And we do that driven by the motivation that you can never capture what's gone on before. You can't go back and capture a lifelog, it's too late. You either capture it now going forward, or you just say, I don't have that data. Now for some data like instant messages off your phone, or maybe some smartwatch data, it is historically stored, or emails. But for stuff like this, where you have to actually do something to gather the data, wear a device, if you don't do it now, you won't have it, okay? So we digitize what we can, and what we should, and what we're legally allowed to do, and all of the other restrictions on an ethical process inside of a university, but we do it without knowing all the use cases. Almost like an app store or an app platform. You have the technology, and then you build things on top of that. So, looking at this, many positive use cases we see. Personal retrieval engines, what I want to talk about today. The ability to search yourself. When did I, why did I, where did I, who did I do something with? That idea, because I see search, naturally my background is as a search engine scientist, as a key fundamental technology. If you can search for stuff, you can build applications on top of that. Personal assistance, where we can have some kind of recommender engines. Look at your data, look what you're doing, and start making lifestyle recommendations, etc. Tell you who you're talking to because you've forgotten their name, all this kind of stuff with personal assistance. Health agents to understand your lifestyle, your potential longevity, give you recommendations for that. A health agent that knows exactly what you're eating and can tell you that's a good or a bad thing to eat that hamburger today because you have an exam tomorrow. It's not a good thing to do, right? That kind of idea of health agents. Safety and security agents to protect yourself. In an era of GANs, generating fake images and fake videos, what's to stop an ex-partner deciding to send your friend some fake video about you? You were at the riots in Dublin City last weekend. Here's a video of you being there. Actually, no, I wasn't. Check my lifelog. Right? That idea. We'll probably end up doing that anyway. And some kind of really cool work now starting on personal knowledge graphs. Encoding what you experience into a linked archive and then allowing you to build cool tools on top of that. But we're going to focus on search, driven by three motivating factors. Sensors are cheap. Disk storage is cheap. And AI tools are now readily available to handle multimedia data. 10 years ago, I would have said, sensors are reasonably cheap. Hard drives are cheap. We didn't really have proper AI tools yet to do this. Now I'll show you what we have in embedding models that works really, really well. So we can now do this, and it should become, I think, as common as wearing glasses, because this will be the platform we'll end up using. How many people have seen Humane's AI clip from last week released? No? Maybe I'll wrap up with a video at the end that shows you the Humane AI clip. It is basically this with an AI engine that basically links into large language models and GPT stuff and just generates real world human assistive agents based on what you see and what you hear. We'll show you a quick video of that at the very end if we have time. Okay, so I think this is going to happen and we're moving towards this anyway. So for this talk I'll focus on wearable cameras. And what I mean by wearable camera, oh no, get the sequencing wrong, is this. Around 2,000 pictures a day. This was at MMM 2020, just before COVID. Actually, COVID was just kicking off then, in Korea, and you can see what it looks like. And of course, there's nothing you can do with this data, right? We spent lots of time eating Korean barbecue, as you do, went to an Irish bar, stayed for 6 hours, got kicked out, as you do. Should be lots of Guinness there. Go home and watch dog TV, because that's what you do after a load of Guinness. And that's about it, right? So we want to make use of that data. Marry that data with locations and activities and communications. You start to build Gordon Bell's vision of what a lifelog could be. Now, the My Life Bits vision I showed you at the very start, that was basically trying to build a MEMX, didn't really do search. It just did a database with database retrieval. It wasn't really a search engine. We were trying to take it a step further. So, part of the process we had was how can we gather lots of information? So wearable cameras, fine, we can buy those, they're easily available. Biometric trackers, smartwatches, fine. Once we can get the data on a per minute basis, Great. Location tracker is in the phone. We can capture our instant messages. We can capture all kinds of content that we're reading by scanning it. Whatever we want to do, we can get data, except we couldn't get this. And we wanted data about our computer usage. And at the time, 2015, 2016, there were no applications we could get that would give a really good record of our computer usage. What I mean by record of computer usage is I want to know every keystroke. I want to know every mouse movement. I want to have a really detailed review of what we do. So my PhD student, Zahir in Bargy, built Loggerman, which I believe still works on Mac, although a new version of Mac has to be updated almost every year now. What it does is it gathers, as you can see up here, smart screenshots. A screenshot every 10 seconds plus when you tab. It captures again, starts capturing again. Keystrokes, every single keystroke that you make, including the millisecond timestamp, as accurately as you can get from the operating system. Keyboard, which basically means words typed. Apps you're using, what you copy to clipboard, historically stored. And 19 different types of mouse curve, because that's what he found that we generate normally. With that data, we build a really detailed, privacy-aware life log of your computer usage. Any image we capture from a screenshot gets passed through an OCR tool and becomes searchable as well. So everything you type, everything you read, everything you access is now part of the search engine. As a side note, we realized that the mouse curves were actually really useful to identify who was using your computer. So within about 20 seconds, we could know if it wasn't you using your computer because your mouse curves were different, right, to somebody else. As well, Alan Smeaton did some work with this as well to understand, is your keystroke identifiable as you? And certain sequences of keystrokes and the time between when you type them in words, those tend to identify people as well from a small group of people who could be. So you can, in theory, build systems that would take this data and lock your laptop if you're not using it and somebody else tries to use it. We never did that, but we thought about it, but didn't have time to do everything, but it's still pretty cool. So the lifelogs you end up making are pretty rich. Here's an example of a lifelog that we would have had from a competition a few years ago. You start off a certain day, and you have your overall biometric data summarized for the day. You have your overall food logs for the day. Food logs at that stage would have been done manually. You would have recorded your own food logs. And then every minute of the day, we have our lifelog data, which will be something like your biometric data at that minute of the day, an image from a wearable camera if you have one captured, which you should have, image from your camera phone if you have one captured there, music you listen to, keystrokes, whatever else goes into here in that minute sits in there. And that's what we released as data sets in terms of allowing people to build search tools. So our first data set was 3 people for a month each with that level of detail of what they were doing. And we'll touch on data sets shortly. What does it look like to build this kind of a digital twin? Well, if we went for 4K video, which I would absolutely love, per year you'd have 16 hours a day, 5,840 hours per year, which will require 342 terabytes. It's not happening, right? We have a rule or an expectation that we should be able to store our lifelog on a $100 hard drive. $100 hard drives don't yet stretch that far, right? HD video will be a lot less, 32 terabytes. We actually use wearable cameras around about 1 million images a year. Fits in half a terabyte. So that now fits into your expanding $100 hard drive over longitudinal periods of time. And then anything else, if you want audio per day, you can press record on your smartphone, leave it, 24 hours later, you've got 227 gigabytes of data. It's not that much. You can process to remove silence, etc., and get some cool stuff out. We don't do it because people won't talk to us if we do, but the concept is there. We could do it, and lots of other stuff takes up almost no space. If you want to go through the detail of that, lifelogging personal big data, it's a bit old now from 2014, but still goes through the kinds of data challenges that we have. Okay, keep moving along. I won't spend much time with this because I'm short of time. Use cases. I'll focus on the bottom. Health and wellness. We should be able to live healthier, better lives by having access to sufficient data about ourselves. Not just your footsteps and your heart rate, but actual data about your diet habits, your calorie intake, etc. Augmented cognition. If we can give people better support for memory, You should be able to access what you've experienced, heard, spoken, read at any point in the future. Augmented cognition. And augmented, okay, not augmenting your cognition, but augmenting your ability to think, or to react, or to work, or to study, or whatever that is. And then leading to augmented citizen, healthier, safer citizens in society. That's the overall viewpoint. We're quite interested in the enhanced memory side up here, where we can and we have done research into understanding how human memory works by using lifelogs. So we would work with memory scientists who have an understanding of how human memory works, and the modus operandi here was using diary studies. So if you want to take part in a memory science experiment, we give you a diary, you write in every day what you did. And a year later we ask you what you did and you try to remember. We took this idea a bit further with lifelogs. This is now really 10 years ago. It's time we did the follow-on study now, where we took a year of a lifelog, a full year every day for a year. We got the lifelogger to working with a memory scientist to identify the 50 most important things you did that year, memorable, important things. And then 6 months later, we asked you to find those 50 most important memorable things using 2 different types of search engines, see which one worked best, and we'll see the output of that. But we could understand where you were mixing up your memories. You may have gone to think about a conference a few years ago. You may forget which one it was that you met at, but you were sure it was MMM 2014, but actually it was MMM 2012. And you think you're right, but you're actually wrong. Many, many cases of that we found. Our memories are just this generated story about our past, not necessarily replaying your past, right? So there's quite a big difference. If you ask Gordon Bell about his memory, he'll say his memory is in the computer. His index to the memory is in his brain, where he thinks how to generate queries to find the real memory from the computer. So these kind of things we can do. How we see this playing out, if you imagine a scenario where a lifelog is a ubiquitous thing, we all have a lifelog of what we see, what we hear, we all have the facility to find anything from our past, then going through life, you'll probably use it when you're a child to support learning. Customized textbooks. The system should know what you know and then should build your learning model around that. We've already kind of started that process. We have a project funded by Microsoft, which is understanding how well are you likely to remember what you've read on a screen by looking at how your eyes are moving across the screen. And we're about 80-something% accurate for that to identify you're not going to remember this, or you are going to remember this, right? So knowledge support, help you to learn. When you're working, should be productivity support, help you be more productive, okay, in your working life. And then finally, when you get older, should be health support. Can we assist you to live an independent, healthy life for as long as you can? Keep people out of nursing homes, have lifelogs helping them, telling them who's come to the door, who they're going to be talking to today, telling them this person at the door isn't somebody safe, you should not open the door, that kind of thing, right? So throughout the whole life, there are different values you're going to get out of this, but broadly, education, productivity, health is what we see it as being. Okay, so the novelty in what we do really tends to be in wearable cameras, because it's the new kind of idea or concept. So let's look at what we do to support retrieval, because retrieval is really, really important, as far as I'm concerned. The original Microsoft camera that came out had a retrieval engine of sorts with it, built in 2004, 2005, and this was it here. It would take the multiple thousands of images a day and allow you to play back a video. And every so often you'll stop the video and say, I was doing this here. Go play again. Oh, I was skiing. Play again. I was having dinner. Play again. And you manually break it up into segments during the day. And that's what Microsoft released as their memory aid back in 2004, 2005. And what we did to get access to the cameras was we promised to build this system here. So in 2006, we said, if you give us the cameras and give us some money, we'll build you a pretty cool system to do that automatically. So this is what we built back in 2006. We take the multiple hundreds or thousands of images a day, and we organize them into a visual diary. So we identified events out of your visual data stream. And an event was just a change in the visual data. that was over an extended period of time. Not like I put my hands in front of the camera, took them away again, that's not an event, but over a course of a minimum of say 5 minutes, the environment has changed. If I walk from in this room to outside on the corridor, it looks different. The colors are different. The textures are different. So by looking at really low-level visual features, we can then identify changes in patterns. Those changes in activities then become our event segmentation. In fact, we did some studies on this and we realized that typically if you segment your day manually into different events, we found people tend to segment a normal working day into 30 different events and less at the weekend, okay? But in a normal day, you do 30 different things is what we found people are naturally segmenting the day into. Like having breakfast, driving to the office, sitting at your desk, meeting a colleague, getting lunch, 30 different things a day. So this was done pretty straightforwardly, actually. It wasn't even machine learning, it was just a rule-based system. And we would identify the most important events by those that had faces. More faces, the better. The longer you have a face, the better. Hence, the bigger images here are the ones that have faces, and that's the most important event in the day. Faces are important for Lifelogs, and I'll tell you later on why we're currently not doing search properly because of faces. Okay, so taking it a step further, built some pretty cool tools as well. This was a visualization of your day in events, where instead of the event being identified by a picture, it's now identified by a dominant color. And a dominant color in this case is the most important color or the most unique color that happens across a string of images that may last for 5 minutes up to an hour, 2 hours. And blue, light blue, is using computer screens. So you can see we're computer scientists. Your day looks kind of like that, right? Lots of computer screens. Yes, there's a shift in the time. Look, computer screens at 0:00, midnight. What was I doing? An inherent requirement when using multiple data sources is time alignment. If you've got a camera working on one time zone, your smartwatch on another time zone, you're dead, right? So we align everything to UTC time, the standard like summertime. I think summertime, Greenwich Mean Time, UTC time anyway. I was in Japan, that's why it looks like I was here in the middle of the night. In Japan, get the plane back to Dublin, back in Dublin, you see the time shift. It's the only way we could actually build the tools to have exactly time aligned across multiple different sensor sources. Okay, keep going. They were all fun. Looked nice, interesting. We started working with partners to actually do something useful then. And this was with the University of Otago in New Zealand. And we've done a number of different projects with universities and institutions like this. This was the Department of Public Health. And they wanted to understand, they had money to do a project to understand children's exposure to fast food marketing. And the typical process is like the memory study. Diary, ask the child, when did you see the Coca-Cola logo? And oh, I saw it last week, right? That's the kind of thing you got back. And it wasn't really all that useful. So they did all the ethics stuff, thankfully. They gave cameras and GPS trackers to 200 children from schools in New Zealand. And they went out for 5 days each, brought back. There was a process whereby the parents cleaned the data, lots of stuff happened in the background. Eventually they got the data. And then they were able to analyze, in reality, manually. We didn't really have that much search at this stage behind this. In reality, manually, they'd tag, they'd annotate multiple million images for the occurrence of fast food. So they spent months clicking on an image. In fact, we built this annotation software for them. They didn't trust the technology to annotate it. It had to be perfectly correct for their studies. So they manually used our interface to annotate every single image of multiple millions of images to say, this is Coca-Cola, fast food, drinks, blah, blah, blah. And then they could do their analysis of what was going on. And they found things like, what was it? 27 times a day children were exposed to fast food advertising. Phenomenal, right? Including on the back of the basketball hoop in the school, was sponsored by McDonald's. So interesting stuff they found. They did the same kind of study for smoking because they were smart enough when they were coding the images. It's what they call the annotation process. They annotated a lot more than they had to, so they could do alcohol, smoking, dangerous environments, cooking activities, etc. And they understood the value of this. This was then replicated in the University of Peking Department of Public Health in Beijing in China to understand Chinese children's dietary habits. And it's been used a number of different times since then. Here's another system. Now this system is much more interesting, much more recent. Working with Deakin University in Melbourne, they wanted to understand the patient journey after the patient left hospital. So an elderly person living alone leaves hospital. They're told to, you know, make sure you do all the usual things like wash your clothes, go out to the park, have some social interactions, have your medicines after your meal, all that kind of stuff. And they found that the elderly people just didn't listen to them at all. So they wouldn't have the very good health outcomes because they just went off and lived their normal lives. So the doctors got involved this time and said, okay, what happens if we put a camera on the old person, send them home, and then the camera uploads the data? Like, it doesn't change their behavior, right? We're not trying to say, no, take your medication now. Well, yet. But at the time, we just wanted to understand the level of adherence. So we had an automatic system which would analyze all the data, generate a description, and then they would start to annotate that description. And this was really interesting because we had some big challenges here. We'd been talking to these guys for a year, and we'd never made enough progress because the computer vision tools that we were using had to be trained. And we could download models that would identify lots of different things, but they didn't identify taking medication or using the washing machine, right? Things that we really needed to care about. We didn't have even enough positive examples of taking medication because once again, there were millions of images here, and we didn't have time to annotate looking for medication. Every picture is there medication in here, is there medication in here. They didn't have time either. So only now we've moved to, and I'll show you examples of it as we wrap up, embedding models. Have we been able to solve the problem? We had forward and back with these guys for a year or longer, meetings every month, trying to get this medicine-taking process working. And we turned on an embedding model, search engine for them, and they've never come back to us since then. It was solved. I'll show what that means. I'll show you what that means shortly. Okay, the other thing that people have looked at is surveillance. We didn't do this, but Steve Mann proposed this from the University of Toronto, that if you are being watched by society, you watch back. The society can't accuse you of something. This is now very important with GANs and with generative AI, that you can't be accused of something if you have your own truth. And your own truth is your own lifelog. So Steve Mann had this idea that the little person should look back at the society. So the society cannot turn around and say, well, you were at the protest last week, you broke into the bank, you attacked that person, and actually, no, here's my lifelog and I didn't do that. Okay, so that's Steve Mann's idea. That's why we'll use this in a useful way. Right, retrieval. As a fundamental requirement, how am I doing on time? Okay, fine. Might even be quicker than that. Okay, super. As a fundamental requirement, we know from 20 years ago that the more metadata you have, the easier it is to find photograph content or multimedia content in your own personal archives. Here was a study from 2004 about how we can use context of images to find your digital photographs, where context includes things like location. And what was really obvious but interesting from this work is that the typical photograph annotation or finding tools were focused on things like date and time. The photograph was taken in 2006 in the summertime on the 15th of August. Easy to find it, right? But people can't use that to find their content. We don't remember. We don't as humans remember when was, let me think a good example. What date did MMM start in 2014 in Dublin? I don't know, and I was the general chair, right? We don't remember our past memories, right? So we don't remember the date and time of things. We found that things like outdoor-indoor detection. Outdoor-indoor reduces your search space very significantly, if you can identify that. Who was in the pictures? Where are the pictures taking place? What event was it? How many people were there? What season was it? Even things like what weather was there, much more important than the date and time. So if you think about what we had done with Lifelogs up until now, that little diary interface, the most important things you did every day, date and time. The colored interface for event summarizations, date and time. date and time wasn't going to work. We had to move to much better tools, which is fine. So we started to build much better tools. Here was the first tool we used for the memory studies. Thinkhotels.com for Lifelogs. Right? That's what it was like. When, where, how many faces. You build up a query. Oh, I was in Klagenfurt in Austria. There were lots of people there. Faces was probably none, few, or lots. Right? Lots of people there. There were a few visual concepts. There were buildings, there were doors, there were faces. Visual concepts of 10 years ago, right? And it was basically weekend, weekday, maybe some weather was in there too. Very, very limited types of search tools. But compared to the browsing interface with dates and times we saw, this found the content 10 times faster because a person could just build a query. Since the query didn't have to be as focused on date and time, they could make much more flexible queries. Like, it was definitely at the weekend. And it was snowing, I'm sure it was snowing. And I was definitely in Austria. And suddenly your search space is way down. Then you can easily find your content. So 10 times faster than searching by date and time. But not only 10 times faster, it was 3 times more successful. So whereas date and time failed, given a 10-minute time frame, we failed to find a piece of content we wanted to find in a 10-minute period when we searched by date and time. 75% of the time we failed. We only got to write a quarter of the queries. And they were for the queries of the top 50 most important things we had done in that year of data, right? We can't even get the date and time right. So once we moved to this, we got it right 75% of the time and 10 times faster when we got it right. This was the way to go. The interface is horrible, absolutely. Nobody's going to use this in the real world, so we have to move a bit further. We started building tools like this tool with Google Glass. Google Glass was not able to capture an image without the screen being on and everybody seeing, unless you got those PhD students who could find a way to solve that problem with Google Glass, could take a picture without having the screen on. Right? So we could go around and have a Google Glass on. It would take a picture every 30 seconds. The picture would go across the network onto the servers, and the servers analyze the picture in 2014 and find what was in the picture. And that was reasonably accurate. In fact, 9 of those 10 things were accurate. But I'm sure Klaus and other people here will tell you, computer vision tools of the time were very much dependent on the source data used for training. And lots of things like computers were very successfully trained. Pizzas were very successfully trained. But unhappy dog, good luck, you're not going to find that, right? So we have to move on to new things. So we started off building a system anyway, and we ran an international competition to build a better Lifelog search engine. The first year we ran this, details will come later, 4 groups took part in 2015. All these groups here use standard computer vision tools like what we were using here. I don't even remember the name of the tool now, right? But standard computer vision tools. One group, LIGMRIM from France, were a computer vision research group. And they went and they had much better tools, whatever kind of fusion models they use of different tools. They were so much better than everybody else to find content because they were better at computer vision. So going forward from 2015, we knew we had to be better at computer vision. But not only we knew we had to be better at computer vision, we knew we had to progress by having other people involved too. My team were really good, but there were only one team of people. Right? We had to do much more than that. So how this works then, we realized, well, at the time, a search engine for Lifelogs looked like this. You got images from your Lifelog data. You had other metadata sources, and people only actually used locations and times. All the other stuff like my computer usage, my walking, my standing, driving, all that kind of stuff, people didn't really use that. We just used images, locations, and times. Images were put through image annotation tools to generate descriptors. Those descriptors then went into the search engine. So an image that it goes in, gets replaced with computer, faces, classroom, chair, mouse, description, image descriptors. And that allowed us to build a first version of a search engine. That was important on the basis that it allowed people to query using text, as we're used to doing Google searches. Not faceted search, like here, no, like here, actual real search engines. So we decided we had to get more people involved. So inspired by Klaus's VBS. We basically copied it, okay? And we took it to a different conference called ICMR, and we did a Lifelog Search challenge. In fact, we did 3 of them. Only one I'm going to care about today is the Lifelog Search challenge. Okay, an interactive search challenge based on the video browser showdown for Lifelog data. And we released a data set. The most recent one was 18 months in size. That's every day for 18 months, every minute of every day there is Lifelog data. The camera's probably only for 14 hours a day, but other data there all the time. And we had about 2,000 images a day. Okay. Importantly, they were automatically face blurred. Right? Our first time we did this, 2016, was manually face blurred, then I'm automatically face blurred. Biometric data, even though we didn't use it that much. Information access data, we end up not using that at all. And human activity data, running, walking, sitting, driving. So every minute of every day had this rich data source, including visual data, during waking hours. And we ended up having to define, as we were doing this, what we call an ethical data release process. Because think about it, if I ask you to give me 18 months of your life experience from your viewpoint, captured visually with all of your locations, all your activities, all the food you've eaten, all the people you've met, you're probably not going to give it to me, right? So we had to regenerate this process where the Lifelogger gathers data. The first thing they do is they clean it and they review it. They look through every single picture. 18 months is about 1 million pictures. There's a bit of work here, right? Then they share the Lifelog with us, and we then have a researcher, a Li Ting, to look at every image, review it, and clean it again, right? Because just because the Lifelogger has cleaned all their data, they may have missed some things. The reviewer should find more stuff. Maybe they might find something that may be offensive in other cultures that the Lifelog hasn't realized, so they get cleaned out. We resize all images from 8 megapixels down to 1024 by 768. Smaller data sets, easier to transmit, but also if you resize down the image, it's harder to read text on screens, like mobile phone screens. It's useful to do that. We then anonymize. We remove every face automatically. Every face gets blurred. It's probably 99-point-something% effective. Some faces always get through. We then allow the person to review it again, and then finally we release it with strict access controls. You only get to use data if you sign up with data usage agreements for the length of time you're doing Lifelog search and nothing else. You sign up to do things like you're not allowed to try to reverse engineer the location of where the people live in the data, all that kind of stuff you're not allowed to do. Plus, if this person ever says, I want to remove an image, you're meant to be able to remove the image. We've never had to do that, but the agreement is there like that. It's a lot of work, right? But it means we can use repeatable data sets. If we have repeatable data sets, we can do repeatable experimentation. That's what information science thrives on. Okay, so what are the queries like for these systems? Well, here was one from a couple of years ago. We had this concept of a temporal query. If you're trying to remember something from the past, you start off by remembering a key feature like Steve Wozniak. And then you go, yeah, there was a picture of Steve Wozniak on a wall of portraits. And then you go, wasn't it in that place that had the brick wall? And you kind of generate a query by building up a query. So every 30 seconds, we would give more of the query to the user trying to use the system. And this has been done in an interactive manner. So you had somebody sitting down at a computer. They were given 3 minutes or 5 minutes to answer the query. Every 30 seconds, you get more information. And the faster you answer the query, the better your score. It's a competition. And in this example here, there was a single picture that had Steve Wozniak on the wall. That was the kind of query that we were looking for. So you had 18 months of data. Find one picture in a million, please. Okay? And you're under pressure to do this. And by the way, the query is getting better all the time. Oh, and sometimes the query is wrong because people remember things wrongly. So we have a bit of that going on there. It was a blue wall. No, it was a green wall, right? That kind of thing. So it's a bit of a challenge. Here was what the competition looked like this year. This was a novice run. We had novices and expert runs. Each of those tables is a search engine. And there's a scoreboard up on top. Now, I want you to look at look at this one more time. You see the guy dancing at the back? Look for the guy dancing at the back of the room. He's not dancing, he's using a VR system, a LifeLog VR search engine. That's his using of the system. It's an interactive challenge, so we start off with experts, the search engine builders, processing some queries, and then we get novices, people who've never used the systems before, just like you. Here, sit down, use the system for the next 10 queries, and a novice uses the system. And that's what was happening there. The novices are being trained how to use the systems in a very short time period. So the scoreboard looked kind of like that. What have we got in time-wise?
Yeah, you have. How many minutes do you? I think you have still 50 minutes.
Okay, fine. I'll be a bit less than that. Okay. So we had, 14 teams take part last year, and the overall scoreboard, the overall scoreboard here, the current query scoreboard here, and the queries coming up here. International, real-time interactive competition, normally done as part of the welcome reception. That means there's wine as part of the process, and it makes it much more interesting, especially for the novice runs. Okay, I'm skipping over years of work here, right? But most recently, we have realized with the advent of better quality image search tools, image search mechanisms, I'll show you an embedding model shortly, the systems got too good. That Steve Jobs query was answerable by somebody typing in picture of Steve Jobs, click, go, result, done. It became that fast because our embedding models we were using for visual search were so accurate, and I'll show you an example, that they were finding answers straight away. So we decided we need more query types. Start off with the first one, known item query. Find something like that picture of Steve Jobs or Steve Wozniak. Ad hoc queries. Find every example you can get of me drinking Guinness beer. There's a lot. Right? And then finally Q&A, much more interesting. What's my favorite brand of beer? Can you answer that question? Think about market research. What would they want to answer? What's the favorite brand of beer? What kind of car do they drive? Is there a correlation between the beer drinking type and the driving type? Okay, all that kind of stuff. So let's look at some examples. A known item query from last year. There was a man in the front row with a yellow hat on. 30 seconds later, I was on a stage in a room with a lot of people watching. I was on some sort of panel writing notes. I remember the man had a blue sweater on, that kind of query. That's solvable by most teams really, really quickly. It's less interesting for us now. It's almost a solved problem. Ad hoc queries. Find as many examples of taking medication as you can, because that's important for many use cases. Or this one here, find examples when I was wearing my yellow Be Happy yellow t-shirt. Okay. Just kind of a strange kind of query, but it's a good query. But this is what's most interesting. Here were real queries from last year. I visited a famous Korean temple with friends a few years ago. What did I do immediately afterwards? That query is taken from the one-day video I showed you. If you remember that video, if you were paying attention, went to a Korean temple and went for tea and cake afterwards. That's a real query. And the answers you give back to this are things like, get a coffee, type in text, right? A real answer to the query. Here's another query from last year. Damn it, my car has a flat tire. What was the name of the car service repair company that I used in the summer of 2019? Tommy Tucker Tires. Okay. And then what airline did I fly most often with in 2019? Nobody got that right, I think. That was really hard. There you got to find out all the different airlines, logos, how often they occurred, and the answer was Turkish Airlines. But that kind of thing is where we're getting to now. Answer questions like this interactively with a search engine really, really fast. So what's state of the art? I'm going to look at 4 systems briefly that I want to highlight over the last couple of years. The first one are the VR systems. Now, I was really lazy. I took Aaron's system here rather than the more recent systems, but the concept is the same. The concept is you build a search engine, the interface is in VR. So maybe you speak a query. In fact, the guys in the group was, which group? Zurich. Yeah, they actually had somebody back home as well that was processing the queries. They'd speak it and they'd be processed through. The person in the VR system wasn't necessarily even entering the queries into the system. There was some kind of communication going on. But they'd have this big VR system. Think Minority Report, think Tom Cruise moving through people's life experience. VR systems. They're extremely cool to use. Your arms get very tired. You won't use it for very long. But in the first ever LSC search competition in 2018, a VR system won the competition. Now, I'm sure Klaus will agree that it was my data. The person who built the VR system was my student. He probably had a good idea of my lifestyle, so had an advantage there. So I never really put too much emphasis on that. Here's a system that Bjorn Johnson built. And I really like this system because this was I'm going to describe it wrongly, but I'll try my best, a real-time model building system. So you'd be able to take, in theory, you start off with 24 random images, choose the ones over to the green side that are most likely like what you want to find, put ones in the red that are least like what you want to find, retrain your model, go again, see what you get back, optimize, 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 optimize. Eventually you should get back down to the images that match your information need. In reality, it was a queryless system. It was a browsing and optimizing system for images. They had to add in a query mechanism after the first year because they needed to focus at least your starting point. But it was a very, very nice system and they do reasonably well. This one won the competition 3 years in a row. And this was a basic Lifelog search engine, had a good back-end system, had a nice clean interface, had a temporal query mechanism. You could do 3 types of queries. Number 1 was what I care about. Number 2 was what I did beforehand. Number 3 was what I did afterwards. Often the queries are like, I was shopping for a Christmas tree after I was at work, before I went for a Christmas party. So we'd have what you're doing in the middle, what you did before, what you did afterwards, mapping interfaces to limit your search if there was a location there. And the back end was very, very good, and I'll show you that system as we wrap up. And then this was the winning system last year, which actually was Life Explorer that Klaus wrote. This beat that system. The first time that system was ever beaten in a competition was actually Klaus's system this year. Actually, do you want to say briefly?
No, I think most
the guys know it already.
It is heavily optimized for fast search with keyboard.
Okay.
I think that's one of the...
So desktop search mechanism. And has clip models, has object detection models, has concept detection models, and text detection models into the search engine. So multiple different sources of evidence coming together, that gets built into the search engine, and a very fast retrieval model and a very clean interface. Was able to win the competition. Yeah, very good. Yeah, makes sense? Yeah. Okay, and then looked like that, very clean interface. And here was an example query, eating food in an airplane. And of course, you can browse through and go through in detail anything you want to go through, go forward and back, see what's inside of each image. Okay. What have people tried to do? I won't spend any time on this. There's a lot of stuff people have tried to build in these interactive search engines. I'll just summarize the ones that work best. A typical Lifelog search engine looks something like this. We'll take in images, we'll apply some kind of an embedding model, because that's where technology has moved towards. We'll have metadata, locations, times, and maybe other source of data, some kind of alignment into a search engine like Elasticsearch. Then we'll allow a user to type in a query. There'll probably be some query parsing. Part of speech tagging. I was doing this before I did this, after I did something else. Extract it out from the query, do a search result, display to the user as images, click on yes or no, or refine your query. That's kind of where we are in terms of search engines. With the embedding models we're using now, that's effective for finding answers to lots of those straightforward queries. Especially since we started, folks, initially we started off using very visually descriptive queries like, there was a man in a blue hat wearing a yellow top. In reality, we don't query like that. We query like, there was some guy asleep in the front row. That's kind of where we really should be getting to, right? So I'm going to show you this system as we wrap up. What does a Lifelog search engine look like now? Text queries, part of speech tagging to understand what's happening inside of the query, break it up into different sub-queries. Concept maybe searches in there, logo search maybe in there, brand search maybe in there, metadata filtering, locations, time, weather, whatever else you can get. Visual embeddings, absolutely, that's how we do a retrieval now. In reality, the best models have fusions of different embedding models and different concept detection models. Probably some relevance feedback as part of the interface. Location filtering in a map maybe there. Event segmentation, like we showed in the breaking the day up into different events. You tend to return back results that are said, that'd be something like, rather than just every image, from here to here you're in the office. So here's the most important images in there. Do you want to go inside this and look in more detail? You go in and you explore that in more detail. Metadata enrichment. Just because we have a location as a GPS doesn't mean it's actually correct. So it'll be some of my students have released extra metadata that says GPS location is actually this restaurant. So we have that metadata enrichment and some kind of an intuitive interface that people can use, especially novices can use. Lots of papers there to look at if you want to look at the LSC Lifelog Search Challenge proceedings. Probably something like 85 papers can be looked at now already. But there are some societal issues, absolutely. I've completely ignored things like ethics and privacy. Yeah. The right to be forgotten. Yeah. We do have ethical approval for our work, even data set release, amazingly. Privacy is naturally a concern. When you release a data set, every face is blurred. Does that mean that anybody that wears a life-logging camera cares about privacy? Absolutely not. But if you want to use spy cameras, you're not using this, you're using something on a pen or something like that, right? So we're not trying to get around privacy, we're trying to build a search tool that can show the value of the technology rather than the privacy implications of the technology. Can you be forgotten from a lifelog data set? Right now it's very difficult to do that because especially if faces are gone, you're kind of blurred out anyway. And then where's the balance between somebody's ability or somebody's expectation to gather a lifelog when they go out in public versus somebody's expectation not to be captured in somebody else's lifelog? There's no clear answer to this, okay? Different jurisdictions have different expectations, so it's an interesting thing. If I put on a smartwatch, it looks at me. If I put on a camera, the only person not in this camera's viewpoint is me. Okay, you're all in the camera's viewpoint, not me, unless I'm wearing a yellow t-shirt in a mirror or something like that. So, but massive opportunities here for research. Technology is progressing to the point where I imagine this will be a standard thing that people will end up doing once the platforms are there to do it. And there's lots of scope for different computer science and related disciplines to have input here. This is an interdisciplinary, multidisciplinary challenge. In reality, most of the lifelog search engines we use are technical triumphs. They're not designed nicely for users and they're not designed for everyday people to use. So there's a lot of work to be done in terms of this. I'll say thank you very much. That book is there if you want to download that book. It's a free PDF. It's old, but the concepts are still reasonably accurate. I want to show the video, or not the video, the example of my scale briefly, and then we wrap up, right? Okay. Tired. Okay, thank you. Yes, by the way. Thank you. Okay, not whiskey, my Optra. Okay, so here. So this was what we typically think is a reasonably, okay, you beat the system this year, but I have access to this demo. So a clip model based retrieval engine. So let's say we want to find something like a query from a few years ago, praying to a golden Buddha in a tunnel. So this is an embedding model, so the system has never seen this query before. It's never indexed this query before, but, oh, sorry, I have to sign in. Praying to a golden Buddha in a tunnel. Right? The system finds the content. Whatever you want to type in, here, find another example. What brand, what type of car do I drive? Now, I'm not doing this because I know it works. I don't think this is going to work. I'm going to show it anyway. This is a question. So what kind of car do I drive? System is going to come up with types of cars here it thinks I drive. Ford, sedan, Volvo. I wasn't really clear enough. What brand of car do I drive? Oh, what brand of beer do I drink? Let's do something that has a better chance of getting right. So this has lots of stuff happening in the background to come up with these answers. Bulmers cider, Budweiser, Sudweiser. Getting the visual thing slightly wrong. Irish cider, and there's examples of the ones I was finding that was actually correct. Okay, I can do any query anybody wants.
What video game did you last play?
I don't play video games.
Oh, let's see what it says.
Okay.
You had some video games in your content. I remember.
That was a previous data set.
Oh, yeah, they just said, okay.
Yeah, look, there's no video games. But how about watching football on TV? Watch football on TV at home. At home is actually important, because if I change at home to, say, in Norway, because I know I watched football in Norway once, it should change to being up in Norway watching football. Right? So it actually does a whole part of speech tagging to identify what you're doing. I can do anything like cooking barbecue, and then watching TV.
There was a theory about the music live concert. Was it Beatles? No.
Oh, that's so hard. That's watching the Beatles rooftop concert on TV. That's too hard. That's even. Here's an example of barbecue followed by drinking beer. Right? How about watching Queen on TV? Because I watch that more. Watching Queen on TV. Now faces are blurred, right? Nothing is indexing Queen on TV, but if we look, hopefully, no, okay, Queen is too confusing. Let's go up Brian May. If you don't know who Brian May is, you're too young. Oh, maybe it's not working. I thought this one worked pretty well. Watching. Okay, so Brian May. Okay, I give up. I got this wrong. So let me see. Queen on Queen music on TV. I thought this was reasonably accurate. Oh, that's Green Day, right? That's not Queen. Is that Roger Taylor? Maybe not.
How about talking to Alan Smeaton?
Ooh, I won't know who Alan Smeaton is, right? Because his faces are blurred. But remember the test query last time? Yeah.
Yes.
Sometimes it even manages. Well, we did do the embedding before we blur the faces, so you do get. That's Malcolm, right? No, Alan's not here. Talking to Klaus Schaffmann. You have two ends there, is that right?
You found Bjorn.
I found Bjorn, didn't find Klaus. Bjorn. No, there's Bjorn.
This is correct. It's very well.
One last one. Lunch with Graham. Oh, well, I got wit wrong. Lunch with Graham, you see? It's actually getting it right. Even though it doesn't know who Graham is, but it just looks like an Irish person, I guess. I want to wrap up with one, just to show you the video. Then we can run. I'm sorry, I'm going to keep you too long. This is my lecture notes series. You guys saw the video today who was in the class. Where is it? Just to scare everybody. No, that's the wrong one. This is the one, sorry. Last week.
Welcome to Humane.
This is the Humane AI Pin. It's a standalone device and software platform built from the ground up for AI. It comes in 3 colorways, got Eclipse, Lunar, and Equinox. There's 2 pieces, a computer and a battery booster. Now the battery booster powers a smaller battery inside the main computer, and this is how we achieve our all-day battery life.
So if you ever exhaust the booster, you just reach into your pocket or bag and hot swap it. This is a perpetual power system that allows you to use your AI pin for as long as you want.
There are no wake words, so it's not always listening or always recording. In fact, it doesn't do anything until you engage with it. And your engagement comes through your voice, touch, gesture, or the laser ink display.
It also comes with its own connectivity built right in, our own Humane network, connected by T-Mobile.
We were able to pack a lot of technology into something really small. It runs a Qualcomm Snapdragon chipset, and that means it's really fast, which is crucial for AI.
It's got an ultra-wide RGB camera, depth sensor, and motion sensors.
And it's got this really special speaker that creates this bubble of sound. It can be really intimate, or it can be really loud.
It has an indicator that we call the Trust Light that is built directly into the AI Pin's hardware via a dedicated privacy chip.
The Trust Light indicates when its input, optical, or audio sensors are active, ensuring full transparency and data security.
The AI PIN privacy chip also protects it from being exploited, which means if it's ever physically tampered with, it will require service from Humane to restore operation.
The AI pin
So you can't
comes with
repair
a
it.
beacon that lets you know when
That's
it
the
has
reality.
something for you. Like messages from trusted contacts or services like cars or food as they come available online in the future.
We don't do apps. Humane's OS runs AI experiences that are on device and in the cloud. The OS understands what you need and picks the right AI in the moment.
What this means is that you no longer have to search for, download, or manage apps. These AIs are
I'm going to jump forward because we're going to be too long.
Hey,
Hey, Anya, can you help me with this demo?
you're right there.
Thanks. Now, of course, you can also use Bluetooth headphones at any time.
Estamos casi listos para enviar la versión final.
We are almost ready to ship the final version.
Great. I can't wait. Thanks so much.
Genial. No puedo esperar. Muchas gracias.
Anyway,
So,
you can
what happened there?
find that video on YouTube. That's last week, AI on your lapel. I actually don't think it's going to be that successful on the basis that it's not an app-based platform. It's limited whatever they tell you that you can do with it. You can't repair it. It's $700. Lots of things going wrong with it. But
It's a subscription model, isn't it?
it's a subscription model too. So yeah, there's lots of things that are not right about it. But the concept is there, right? In a pretty big launch of something. It's like Google Glass style launch of something. So we're kind of getting towards a point where a camera is not such a strange thing here. Okay, that's about it. I'm over time, I'm sure. Thank you.
Thank you very much. Okay, great. So, are there any questions? I'm sure there are. Maybe I
Enough from the
start.
class, they've seen everything already.
Yeah. Okay.
If I'm allowed. So I'm in video games actually.
Okay.
And we do a lot of experience. So people really enjoy experiences. And as you said, memory is not like experience. So people remember things differently.
Yes.
So having a great trip to a mountain where it was 99% raining, but then
Yes.
you're at the top,
And you
great
remember
weather,
yeah.
and it was not cold anymore, and
Yes.
you remember exactly that 10 minutes. So do you think that this is an application where you can access experiences instead of memories?
Okay. So I would say that it's an application where you can certainly get access to your memories better by having the index into your memories and the reminders that come from seeing what you've done before. How much do you have to capture to regenerate an experience, I guess is the question. If I have an image every 30 seconds, it's only regenerating your memory of your own experience that you're going to get back to. So you may look back at data and go, oh yeah, Klaus was there, I remember that now, and there we had coffee and so I think you're regenerating, you're refinding your experiential memory, you're not regenerating the experience. We'd need video and audio and all the other stuff to actually go back and give you that real feeling of being there. And maybe you'll get there, but we don't have that facility yet.
Any other question?
Anybody going to buy this pin?
They have more for it, so I'm not sure.
Okay.
Yeah,
It's too expensive.
I have a few questions actually. So
Oh, no.
the first question is, I'm not sure if everybody noticed, but you're wearing also a logging ring, right?
I am, yeah.
And the question is, what can you actually do with it?
It's like a smartwatch, that's all. It gives you access to your sleeping patterns and your activities. That's really it. And maybe your blood, your heart rate. Nothing else. It's just only that. But I like it because it doesn't waste battery on a screen. It just actually just gives you the data into your phone. And it lasts for a couple of days, unlike the watch, which lasts for about a day and a half now. So it's just like a smartwatch without a screen. But it's convenient, just a little bit too thick, so you feel it's on your finger. But other than that, it's really convenient. Convenience is really important for life logging because you can't be expected to do anything extra in the course of your day. Like with this, I didn't go through the video properly, but in order to actually display what's going on, you have to hold your hand up and start moving gestures like that. and you have to speak to it. It's not really designed for an open environment where people are watching you with this hand thing going and seeing what, speaking to your hand, exactly. Maybe a bit of getting used to that. Like in reality, voice interfaces in the real world haven't taken off. Right? Yeah. And now this, he says you can use a Bluetooth earpiece, fine. You still have to speak to it. Right? So there's lots of little issues with this that I'm not sure about. Yeah.
Okay, and another question is, how does GDPR actually affect lifelogging?
Yeah, that was really interesting. So before we ever released the data set, we sat down with our university GDPR data governance guys. And we said, what do we have to do to release a data set? And I was fully expecting them to go, you're not doing that. Right? And then I would have had to figure out something. But he said, that's okay. You want to release a data set? That's okay. Visual data? That's okay. Does GDPR impact that? Not really. Is anybody identifiable in the data set? And I was like, we can blur the faces. And he's like, you don't even have to do that because you're not identifiable. Even if it's your face in the data set, to the general public, you're not identifiable. Or I'm not identifiable. Nobody in this room is identifiable unless we have your name as well. So it's not identifiable to you except to a very small number of people who know Klaus. Right? So he said we didn't even have to blur the faces to release this in a GDPR compliant manner. Now we did because I would have felt much less comfortable releasing all these. Imagine how many faces you meet in 18 months, data out there. But we didn't have to do that. And we have these usage agreements, so we're almost passing responsibility along to, you've signed up to a use agreement, so you have to use it in that kind of a way. So it hasn't really impacted on us that much. We did find when we blurred faces first, we missed things like in a meeting you may have somebody with a face and a name badge. We forgot to blur the name badges, so then somebody was identifiable. The name is more identifiable than the face. And in most cases, names aren't attached to people in the real world.
Right.
But then you have to blur the conference badges too.
You do, and you have to blur their name badges in a meeting. Yeah, so you have to go through quite a lot of blurring. In fact, if you just blur the names out, it's better. Yeah. More concerning will be things like an email on a computer screen. Yeah. So we end up blurring computer screens as well. We downsized, and then we had to blur computer screens again, because it could be student matched to student number matched to exam mark goes out in the data set, and that's going to be a problem. So that's more concerning than just the presence of a face.
Okay. Any other questions? I've one final question. Otherwise, yeah. In your talk, you mentioned that actually we can never know what we are going to do with the data. So, did you have some examples? Do you have some examples from your life when you realized, I can do this or that with that?
Times actually found it useful. There were a number of times. I'll give you two very simple examples. Parking tickets. I had parked and I'd bought a ticket, and this was many years ago, in a town outside Dublin on the way to a meeting. And I get in to get a cup of coffee. And when I closed the door of the car, the ticket had turned upside down. That's all. Simple little thing, little piece of paper turned upside down. And I came out and there was a sticker on my car saying, you're going to be fined. So I was able to go back to the data, pull back the fact that I bought the ticket in the machine, put it in the car. It was upright when I had the door open on the car. Send it to the company and they said, okay, leave us alone. Don't come back to us with this stuff. We can't handle this. Same thing again, I was in Switzerland and I lost the receipt for my train ticket, but the data had the price on getting the ticket from the machine, and I was able to send that to the finance department, who wouldn't have paid it back normally, but it's like, okay, leave me alone. Other things like, yeah, sure, analysing of how many hours you spend in front of computer screens. It comes back very visually when you see the data. Your lack of sleep, all this kind of stuff comes out very clearly from the data. Okay. People you've met who are now gone, you would have access to all those kind of last times you spoke to somebody. All that kind of stuff is really, really useful. So lots of little examples like that.
Great examples, yeah. Yeah, okay, one more question here, please.
How much did the quality of the images change over time?
Oh, super question. So we started off with the Microsoft camera, which was actually VGA resolution, 640 by 480. And the images were so heavily compressed to fit on the SD cards inside the cameras that they were like 25 to 35 kilobytes in size. They were really, really poor quality images, but enough to actually understand what you were doing and to use that data. We're now using 8 megapixel pictures, which are reasonably good. Still isn't great in darkened rooms or darkened environments, and still isn't great when you're moving around a lot. They do have accelerometers that will try to minimize the risk of capturing a picture under a lot of heavy movement. Especially the first Microsoft SenseCam would capture a picture if it's swinging at the top of a swing when the accelerometers are at their smallest movement. But they just get an awful lot better. Yeah, they're actually reasonably good quality. If you get a good, nice framed viewpoint, because remember, you're not framing a picture here. It's not like you're taking out a camera going, I want to take a picture here. You're just capturing whatever's in front of you. So we've done some studies, and about 4% of the pictures we capture will be something that you would want to look at again, right? So if you look at those 4% of interesting pictures, then each of those now could be printed and displayed, and it'd be reasonably good quality. But for the competitions, we just reduce the size way down. Okay, thank you very much. Thank you.